Hey everyone, in previous DLC series of tutorials we talked about decorators, multiplexers and Shannon expansion. If you haven't watched these videos, please watch them. They are also really necessary for your final exam. So from now on we're going to talk about flip-flops or basically sequential circuits. Consider this example or this question. You have two inputs, W1, W2, and you have one output, Z. This function produces only one if and only if W1 and W2 are same for the 4 consecutive clock cycles. What does it mean? Sequential circuit receives inputs constantly at each clock cycle. So if for 4 consecutive clock cycles, as you can see here in this example, if W1 and W2 are same, your Z is gonna be 1. So you don't firstly have to draw a state diagram. You have to kind of allocate the states for the particular cases, and state diagram says what? For the specific input for the particular state, what state comes next? For example, if you receive 0 and 0, what comes then? What state comes? Okay, this kind of question. But before drawing this, we have to kind of create one new or one additional input, or let's say a variable. Let it be k. I guess we need this k, and this k will be equal to W1 XOR W2. When W1 and W2 are same, when they're 0, 0 or 1, 1, as you know, XOR produces 0, okay? And what does this mean? When k is 0, then W1 and W2 are same, okay? This is gonna be our condition. We're gonna find out, actually this is W1, this is W2. How are we gonna find out whether W1 and W2 are the same? By checking the value of k. If it's 0, they are the same. If it's not, they are different, because XOR produce, if k is 1, then W1 is not equal to W2, because XOR produces 1 only when inputs are different, okay? Only then XOR produces 1, okay? This is the truth table of XOR. So we need this k, and we have this k. So say we have 4 states. Why? Because the function produces 1 only when for 4 consecutive clock cycles. When 4 values, 4 consecutive, or let's say, when 4 consecutive values of W1 and W2 are the same. 4, okay? 4 means we have 4 bits and 4 states. Let's say this is not 0, but let's say we have A0, A1, A2, A3. So for A0 bit at index 0, 1, 2, 3, these are the bits, these are the values, the values of W1 and W2, okay? The same values, for the cases when the W1 and W2 have the same value, okay? So if so, okay, this A is responsible for A0, this is for B, this is for C. I will explain it now. What I mean is that, let's say we are at state A. What if our K is 1? We're gonna go back to ourselves. Why? K is 1 means what? K is 1 means the W1 and W2 are different. We want them to be same. We want to be same. So only if they are same, we're gonna go to the next state, to B, okay? If not, we're gonna come back to the initial case. A is our initial case, initial state, okay? Because it is responsible for the initial bit. What I mean is that for 4 bits to be the same, all bits should be the same, but if you start from the beginning, first bit should be the same, then second, then third, then fourth, right? if the first bit is not the same, we should come back to the first state. Okay, let's say first bit is the same, W1, W2 are the same, equal. If the second bit is the same, we go to the next state, third bit. But if the third bit is not the same, then our consecutive 4-bit this expression will kind of crash. I mean, let's say we have 0, 0, and then W1, W2, 0, 0, and then W1 is 0, W2 is W1 is 1, W2 is 0. Then it crash. We can't take 4 consecutive bits, 4 bits, okay? So we again start from the beginning. Count 0, 0, or 1, 1, or 2 consecutive bits. Again, 1, 1, or 3 consecutive bits. But if we have 0, 1, again crash because no 4 consecutive bits are seen, okay? So what I mean is that this first case state is A, second state is B, third state is C. So if any of this B, C state has the 2 different values of W1 and W2, we're gonna come back to the initial case, okay? We're gonna again look from the beginning, okay? So I hope it makes sense for you. So let me come back to the state diagram. So if K is 1 means what? W1, W2 are different, we're gonna come back to the initial case, initial state. But if K is 0, we're gonna go to the next state. We're gonna go to the next bit, okay? First bit is the same, so let's look at the second bit. If the second bit is the same, that means W1, W2 is equal. We're gonna go to the third state. We're gonna look at the third bit. Is the third bit also the same? Okay? That means when K is 0. K is 0 means W1, W2 are the same. So if the third bit is also the same, we're gonna to look at the fourth bit. Okay? Because if the fourth bit is also the same, then our Z is gonna be 1 because in our case, 4 consecutive bits would be the same. Okay? K is 0, K is 0. So there is a question. If at second bit, if the second bit is if the second bit of the W1 and W2, let's say different. If the K is 1, what happened? We go again to the first case. We again look at the first bit because we will crash the 4 consecutive same bits, okay? If at C, if at third bit, if the third bit is not the same, although the first bit and the second bit is the same, if the third bit is not the same, so we're gonna again go to the initial case, okay? Initial state. We go start everything from the beginning. We look again at the first bit, okay? Yeah, this is K is 1, K is 1. So, yeah. And let's come to the fourth bit. If now we at D. D is responsible for the last bit, fourth bit. Now, if we are at D, that means if we are at D at this state, that means we have 3 consecutive same values of W1 and W2. Okay, so in order Z to be 1, we just need the fourth bit also to be the same for both W1 and W2, okay? So now, let's analyze. If the fourth bit is also the same, okay, W1, W2 are same, and K is 0, what happens? What state comes next? We again go to D, okay? We again go to D if K is 0. Why? Because, there's no point of going to A because see, if K, let's say, in order to understand why when K is 0 we go again to the D, you should understand that what happens when K is 1. What happens when W1 and W2 are not the same? Let's say for 3 consecutive bits, W1 and W2 has the same bit, but what if in the fourth bit is different? Again, we go to the beginning, to the initial state, because doesn't matter whether the three states, not three states, 3 bits are the same. If the last 4 bit is not the same for W1, W2, we again go to the initial state. So that's why if K is 1, I go from D to A. So I can go when K is 0 also to the same state. There's no way for ambiguous inputs. Okay, you can't just point to the same state for 2 different inputs. Okay, I can't just say that when K is 0 also, when K is 1 also, I go to the initial state. No, I can't do it. So that's why when K is 0, D goes to itself. Okay, and now tell me, at which condition that is gonna be 1? At which condition our function produces 1? Of course, only when at D we have K0. Is it so? Yeah. Okay. So when three consecutive bits are same, and when at 4th bit also we have K0, which means W1 and W2 are the same, that means 4 consecutive bits are the same, and then will produce actually our function produce 1 signal. In all other states, at A, at B, at C, our Z is 0 because for example at C we know that only 2 at C, this is C, we know that only 2 previous bits are the same. Okay, so we don't know about other bits. We need 4 bits to be the same. So again at Z, at D, when Z equals to, no, not Z, but K equals to 0, Z is going to be equal to 1. So this was our state diagram. So now let's draw the state table. Okay, this is the present state. Next state. Okay, next state. Let me draw it like here. Next state. This was state diagram. Now this is state table. So our present state inputs are W2 and W1. Okay, this is A, B, C, D. We have 4 states. So when K equals to 0, when K equals to 1. Okay, next state, and when K equals to 0 and K equals to 1. So okay, so let me analyze. So see, when we are at state A and when K is 0, K0 means W1 and W2 are same. Our next state is gonna be B, right? At B, when K is 0, our next state is gonna be C. At C, when our next K is 0, it's gonna be D, and at D, it's gonna be D, right? We already talked about it, right? But when K is 1, when they are not the same, when W1 and W2 are not the same, we always go to the initial state, which is A. Okay, we start everything from the beginning. We start counting from the beginning. We should count till 4. Till 4 we should count, so that 4 consecutive, these 4 bits are the same. We should count till 4. Okay, so those we start from the initial state, and our Z is gonna be, for all values of K1, our Z is gonna be, this output Z is gonna be 0, and for K also to be 0 is gonna be 0 for ABC states, but only when K is 0 and we're at D state, our Z is gonna be 1. Okay, right? So we already talked about it, and let's say our next states are pointed like big Y2, big Y1, big Y2, big Y1, and I'm gonna write the binary representation of the states. We have 4 states, right? We have 4 states. In how many bits do we need to represent 4 different? 4 states. 2, right? 2 bits. So I'm gonna say this is 0 0, this is 0 1, this is 1 0, this is 1 1. Okay, you understand, right? I'm just indexing the states. So this is 1 0. Okay, let me quickly write it. 0 0 0 0 0 0 0 0. So now your task is to use a K-map, Karnaugh map, and find the expression for W2, W1, which are the next states. Okay. Now we'll use K-map. So let's see firstly Y1, big Y1. So we have how many inputs? 3 inputs, right? W2, W1, and K, right? K is also important. W2, W1, and K. So we have 2 values of K, 0 and 1, and 4 values of 4 cases for W2 and W1. 0 0, 0 1, 1 1, 1 0. So I'm copying the values. I mean, when K is 0 and W2, W1 is 0, our Z is what? Not our Z, but our Y1 is what? Our Y1 is 1, right? See, look at, no, sorry. See, look at this column. Okay, Y1, this is Y1, this is Y1. So when W2, W1 is 0 and when K is 0, our Y1 is 1. Okay, so I'm copying these values, in the following rows. So they're going to be what? 1 0 1 1 0 0 0 0. So now we're going to do K-map. You take this and this, okay, and you get this 2, okay. So if you do the K-map, then you will find out that Y1 equals to K prime, because you know this is what? This 2. This is what? This is K prime, K0, not K prime but K bar, and what? What is the same here? W1 is same, right? 0 0. So this is W1 bar plus, and what about this one? This 2. Again K bar, because we are at this row when K is 0, and we look that W2 is the same, 1 1, so W2. So this is the value of the big Y1. So this is the next state. So this is the present state. This is the next state. This is the present state, okay? Present state. Present states. And K, you know, is the value of W1 XOR W2. Okay? So now, if you have inputs, you can put it, I mean, W1, W2, K, and substitute, and you may find out the next state, okay? I mean, this kind of stuff. If you have this A state, and then you pass the 0 0 to W1, and also if you put 0 for K, finally you will get 0 1, which is the B state, okay? So now we come to Y2. I guess you have no problem with K-map. If you have problem, you may watch the video in our YouTube channel for K-map. So 0 1 0 0 0 1 1 1 1 0. So I'm copying now this row, values of this row. See, okay, in green for K1 and K0, and these are the present states, okay? So I'm copying this and this row's value, corresponding values to the K map, and you will have this one, values 1 1 1 0 0 0. So I'm gonna take, I can take 3, I can take only the I don't know, the cells, the number of cells is in the power of 2. I can take this 2 and this 2. If I take first this 2, it's gonna be, of course, K bar. I mean, this is 0, and as you can see, W1 is the same, right, for the both cells. So it's gonna be W1. plus if I consider this second two cells, again k bar, because we are in this row where k is 0, and if you see that here w2 is the same, right? This is 1 and 1, so w2. So this is the value of big y2. Okay, so this is the final answer. So let's analyze from the beginning. You had this condition. Okay, this is a condition, and from condition, firstly, you derived one most variable k to check the condition. You need to check the condition, and for this you need extra variable. So this is extra variable to check the condition. Okay, so then you just build the state diagram. Okay, for 4 consecutive clock cycles, 4 same bits. What does it mean? 4 states, and for each bit, as you can see here, for each bit we allocated states. Okay, and we analyzed that for which input we're gonna, for particular input, which state are we gonna go. For example, at state A, if k is 0, that means if w1 and w2 are the same, which state we're gonna go? We're gonna go to the B state, and that kind of stuff. We analyze it, we build a state table, we indexed our states, which is really important. Indexing is important to build Karnaugh map, and then we build in Karnaugh map, we found the expression for the next states, w2, not w2, big y2 and big y1.